Today we're finishing 16.2, which is exponential growth and decay. We did some growth equations already, and now we're going to be on, actually I'm going to jump right to the decay now. So we're going to go to example 2. Example 2, we're still going to write the function, so write the equation. We have to graph it, so make sure you have graph paper. If you need some, go get it from my table. We need to figure out what the domain and range is. It does not ask for the asymptote for these ones, but it does say what does the y-intercept represent. So I'll put y-intercept meaning. So what does it actually mean in the word problem? And then if there's any questions the question's asking, obviously we have to answer those as well. Okay, so for 2a, now we're going to be dealing with decay. So that is when things go down in value. So the ones we were doing were when things were going up in value. Today we're going to first start talking about population. So a population in a town is going down. So for whatever reason, people are moving out of the town. Maybe there aren't enough jobs. The population is decreasing 3% per year. So not a lot, but it is going down. In 2005, there were 1,600 people. And then it says find the population in 2013. Okay, so some important things to notice. We're decreasing, so that tells me it's going to be a decay problem. Also, in 2005, that's the starting point. So 2005 will be your starting value. Or it won't be your starting value. It's your starting year, your starting point. So that 1,600 is going to be your starting value. So in 2013, you have to think about how many years later that is from 2005. So when you go to figure this out, you're not going to plug in the number 2013 because it's not asking from the beginning of time. It's asking from 2005. So they started figuring out this population was going down in 2005. I'm asking about the population in 2013. So first, figure out how many years later is that. So from 2005 to 2013. Okay, tell your table, how many years later is that? That's 8 years later. So keep that in mind because when we have to figure out that population, we're actually going to use the number 8 because it's 8 years later. Okay, so first let's go ahead and figure out the equation. So for decay, the equation is y equals a times 1 minus the rate to the t power or the x power. I don't care if you use x or t. Okay, let's fill this equation in then with the numbers that we know. A stands for the starting value, so the starting population. We started with 1,600 people, so put 1,600 in for A. And then we're going to do 1 minus. Okay, the rate is this 3%. 3% as a decimal. So right now, 3% really has 3 in a decimal point right there. We need to make this into a decimal. So to convert a percentage into a decimal, we move it 2 spots to the left, right? So the percentage is 0.03. Make sure it's not 0.3. 0.3 would be 30%. Like that population's going down pretty quickly then. 3%, it's not going down very much. And then it's to the x power. I'll put my y in there. Okay, and then just simplify this. So simplify the 1 minus 0.03, and then this will be our final equation. Y equals 1600, parentheses, 1 minus 0.03 is 0.97, and then to the x power or to the t power, I don't care. So there's your first answer, that's your equation. Okay, next we're going to graph this. So to graph, you need to grab some graph paper. We're dealing with a real world situation, so we probably don't need the negative numbers in there. Everybody's graphing. You're not just watching me graph. Okay, let's make our x-axis. What did I do in the last class? We're going to go by 4s. Because the graph is, or the decay is only 3%, it's not going down a whole lot every year. So we're not going to see a whole lot of change those first few years. So I'm going to have the years since 2005. Years since 2005. That'll be my x-axis. So in 2005, that's when it's 0. So 0 years since 2005. So that'll be the population in 2005. The rest of these, let's go up by 4s. So if you have space to get up to 32, go ahead and do that. So have your x-axis intervals go by 4s. And the reason I'm having it go so far out is so that you can see the change. Because right now, if something's only going down 3%, it's only going down a little bit. So you're not going to see a whole lot of change until you start going way out. My y-axis is going to be the population. And that population starts at 1,600 people, and then it goes down. So that means I need to make sure I hit 1,600 on that y-axis. So check if you have space to go by 200s. Yeah, I do. So I'm going to go up by 200s. And then when you're ready, go ahead to Desmos and type in the equation. So when you go into the table, don't forget you're not going by 1. So don't figure out like where it is at 1. Figure out where it is at 4, at 8, at 12. So at 0 years, there's 1,600 people. So go to 0, 1,600 and put a dot. Now go down to 4 years. At 4 years, there's a little over 1,400 people. Then at 8 years, Everyone should be making their graph right now. No one's just sitting there watching me. Go to 12 years. $16 years. And then when you have your dots, connect it with a smooth curve. So you'll notice, especially because the intervals are so far apart, they're 200 apart, your dots are probably off a little bit. So don't make your curve like be jagged. It needs to be a smooth curve. You might have to move your dots to adjust to the curve. Don't move your curve to adjust to those dots because you are guessing where those dots went. So you're probably off by a little bit. So some of my dots don't look like they're lining up with the curve, so I got to re-go in. I have to go back in and readjust those dots. Like I can see some of my dots are too far up, so I got to just go back and kind of re-put them back in and line them up with the line or the curve that I created. And then put an arrow on it because that line or that curve is going to go on forever. So create your curve and then fix your dots because your dots might be too far up or too far down. Your curve should be nice and smooth. It should not be jagged like a heartbeat. And then when you're ready, glue that into your notes. And then we're going to do domain and range. Okay, domain is going to be your x values. So if you look at your graph, and only look at the x-axis. So if you want to, just ignore this y-axis, those intervals. If I only look at the x-axis, the smallest x that I use is 0. And 0 does have a dot on it. So I put a bracket on the 0 because it does have 0 years. Comma. Now the biggest x that I could use. Well, I could keep going on. I could figure out at 100 years, 200 years. So I can keep going on forever. So it gets infinity. And infinity can never be touched, so it gets a parenthesis. So if it touches it, it gets a bracket. Doesn't include it, it gets a parenthesis. So infinity can never be touched because it's not actually a number. So it gets a parenthesis all the time. Okay, range, that's your y values. Now this, be careful. Some of you are going to want to start with the 1600. Don't start with the bigger number. We start with the smaller number. So the smallest y value that I can use. This line, this curve, is going to keep going down forever. Or if I look at my graph, oops, I need to adjust my window. We'll do -10, we'll do 200. Y maximum, we'll do 2000. So see, this graph goes on forever, but it goes down. It's going to get really close to 0. It's never going to touch 0 though, because the graph can never touch 0. So the smallest number it's going to get to is 0, but it will never touch 0. So it gets a parenthesis because it can't touch 0. So for the y-axis, the smallest number will be 0, but this curve will always get really close to 0. It never touches 0. The biggest y value I ever use is 1600, And it does touch 1600, so it gets a bracket. Bracket means it touches it. So 1600 is included, so 1600 gets a bracket. It won't ever hit 0. It gets close, but it never hits it. Okay, next thing it asks for is what the y-intercept represents. So it just means in context of the word problem, what does the y value mean at 0, 1600? So the y-intercept represents is the population in 2005 when it started to lose people, or when the population started to decline. So whenever they decided, like, we need to start keeping track of the population, which was 2005, that's what the y-intercept represents. When they started keeping track, it was at 1,600 people in 2005. And then the last thing we have to do is answer the question, the original question from the beginning. Find the population in 2013. So in 2013, there were blank amount of people. So this is the one where I said you are not using the number 2013 because the starting value was in 2005. So we're actually going to be using the 8 because 2013 is 8 years later. So you're going to take this equation, plug this into Desmos or your calculator, but put an 8 in for the years for x. So put in 8 for the years. So I'm going to go into my normal calculator. Everybody go ahead and do this, because some of you don't know how to put in an exponent onto your calculator. So put in 1600, parenthesis, 0.97, and then raise the whole thing to the 8th power because it's 8 years later. Hit enter and see what the population is. I want to make sure you know how to use that exponent. So make sure you put an 8 up there. Okay, we're going to get a decimal. We're talking about a population of people, so let's round to the nearest whole number. We're not going to use decimals. So it's either going to be 1,253 people or 1,254 people. You have to look at the next number, so the 9 tells me to round this up. So there's going to be about 1,254 people in that town. Okay, we're going to do this again. So it's another decay problem. This one we're talking about a car. So most of you are familiar. You guys understand that cars depreciate in value every year. So I have a car that depreciates, bless you, at 5% per year. So when you buy a car, it goes down in value every year. The car was bought in 2010. The car was worth $32,000. So when you first bought the car, it was $32,000. It's going down in value. Depreciating means it's going down. It's going down 5% per year. Find the value in 2013. Okay, first we have to come up with the equation. So to write that function, that exponential function, It's always y equals a times, this is depreciating, which means it's going down. So we're going to use the 1 minus the rate to the x power or the t power. Okay, go ahead and see if you can fill that out by yourself. Come up with the equation. 32,000. Then it's 1 minus 5% as a decimal is 0.05 to the x power. So your final answer will be y equals 32,000 times 0.95 to the x power or to the t power. I don't care. So double check if that is your final answer. Okay, for this graph, I'm not going to have you guys do it by hand. You can just put it into Desmos or put it into your graphing calculator. So go ahead and type this in. Keep in mind, most of your graphs are probably a 10 by 10. So when you hit graph, if you're thinking, I don't see my graph, there's no graph there. It's because, remember, the graph is at 32,000. Your car is not going to be worth $5 or $10 for a pretty long time. So you need to expand your window so that the y-axis can get all the way up to $32,000. So you might, if you're doing Desmos, you need to pinch the graph to make it zoom out. You have to zoom way out until you can see where it is at 32,000. If you have the graphing calculator, you're going to want to change your window. So I'm doing 32,000. If you have a graphing calculator, here's how I change my window if you need help on that. So right now, my window's set for my last. Actually, I'm going to leave a -10. Okay, so for my x values, I'm going to go up to, I don't know, 100 years. Yeah, I'll leave that. I'll go by ones. My y maximum, I know I need to hit 32,000, so I'm going to go up to like 40,000. Now you can see your graph. Okay, so everyone sees it's coming down. Now we have to come up with the domain and range. Okay, with your groups, see if you can come up with the domain and the range for this graph. Will be 0. I can figure out at 0 years how much that car is worth. Yeah, the car is worth. So 0. It does hit 0, so it gets a bracket. And then the years will go on forever. So they're going to go on to infinity. Infinity can never be touched, so infinity always gets parentheses. The range is the price of the car. So the smallest the car will ever be worth, it gets close to, is 0. It never hits 0. So put 0, but put a parenthesis because it will not hit 0. The most the car is ever worth is at 32,000. And it does hit 32,000, so it gets a bracket. So a bracket means it does touch it. Parenthesis means it does not touch it. Okay, next we have to do, what does the y-intercept represent? Okay, go ahead and write down, what do you think the y-intercept represents? Represents the original price of the car. Or you can say the original price in 2010. And then the last thing we have to do is actually solve the problem. The question was asking, find the value in 2013. Okay, go ahead and figure out how much will that car be worth in 2013. Remember, you're not using 2013 as your x because our starting value was in 2010. So first, figure out how many years passed and use that as your x value. And then we're talking about money, so keep that in mind when you write your answer. So 2013, that was 3 years later, right? Because from 2010 to get to 2013, that's 3 years. So I'm going to use this equation. I'm going to plug in a 3 for x. So $32,000 times 0.95, and then raise it to the third power. Enter. It comes out to exactly $27,000. Well, not $27,000. $27,436. Questions on how I got that? Okay, you ready to do one with your groups? Okay, this one we have a boat. And boats are just like cars. They go down in value every year. The boat is depreciating. $9% per year. In 2006, it was worth $17,800. Find the value in 2013. A boat is depreciating 9% per year. In 2006, it's worth $17,800. Find the value in 2013. So for this, I want to know what's the function. So come up with the equation. You can graph it just on your calculator. You don't need to get graph paper for this one. I want to know the domain, the range. I want to know also what's the answer in 2013. What will it be worth? Okay, go ahead and work on this with your groups. Okay, the equation you should have come up with is 17,800 times 0.91 to the x power or the t power. The domain, the smallest x you used is 0, and then it goes on for infinity. The smallest price of the boat is going to get close to 0. Oh wait, it is not a bracket, it is a parenthesis. It's not going to hit 0, so 0 gets a parenthesis. And then the biggest price or the highest price is that $17,800. And then the cost. In 2013, that's 7 years later. So you had to plug 7 into the x right here. So if you do this equation and you plug a 7 in for x, the cost of the boat will be about $9,198.35. Okay, then we're going to move on to the last example. Everybody's so far so good? Okay, last example for this, example 3. For example 3, it's going to give you 2 graphs. Now these graphs, I'm not going to make you guys draw them in. You could either look at the graph on Canvas or look at it up here. So if you're on Canvas and you go to my notes, so my 16.2 notes, the last page looks like this, and it gives you a graph. You're going to come up with the equations for both of those graphs that are on the same graph. So these are 2 different graphs that are showing stock values. There's 2 different stocks. This one that's kind of pink, it started high, and it's coming down. It has a decay. Stock A is going down in value. And then the green one, it started off down here, but it's increasing in value, so it's a growth. So we're going to take both of those stocks and come up with the equations. You need to take good notes during this, because I know a lot of you guys struggled with the question on the review from Friday, where it gave you 2 points and you don't know how to write an equation. So that's all this is again. So let's do that. Make sure you're taking really good notes. So first we're going to start with stock A. First we have to write what's the initial value. So when you bought the stock, how much you purchased it for. So stock A, I'm asking about the y-intercept. That's when you first bought it. In 0 years since you purchased it, the value of stock A was up here at 16. So stock A was $16 per share when you bought it. Okay, then it's coming down in value. So you should get a value that's less than 1 because it's a decay, it's coming down. So to come up with the B value, that's when you need 2 points. And it gives me the 2 points on the graph. So go ahead and write down those 2 points, 0, 16 and 1, 12. 0, 16 and 1, 12. They're on the graph. I have to come up with the decay value because it's coming down. That's B. What I'm asking for right now is your B value. To find the B value, we do y sub 2 divided by y sub 1. The order does matter. This is not linear equations. Linear equations, it didn't matter. You can make it either point your first point, either point your second point. Here, when you're doing these exponential growth and decay, it does matter. You have to go in order from left to right on what's your first point to what's the next point. So this has to be y sub 1. This has to be y sub 2. You can't switch them. So this is your first y value. This is your second y value. Like when you have a point, it's x and y, x and y. This is x, y, x, y. This is your first y. This is your second y. So to come up with the decay value, the y sub 2 is 12. Y sub 1 is 16. Make sure you're taking good notes, because some of you guys look back at your notes and you have no idea how to redo this again. So to find the decay value, that's your B. 12 over 16, I can reduce that. Go ahead and reduce 12 over 16. Either use your calculator, use your brain. 4 goes into both 12 and 16. 12 divided by 4 and 16 divided by 4. Okay, so now I have my B value is 3/4. And I know it's decay because it's less than 1, so it's coming down, 75%, 0.75. Now I have to write the equation. A few minutes, let's just finish this. The equation is always going to be y equals A times B to the x power. So y equals, our A is the initial value, so 16. B is that decay value, which is the 3/4 or 0.75 to the x power. Or t is fine, I don't care. Y equals 16 times 3/4 to the x. Let me get them started on this one, Dana, and then I'll write you this. Okay, so we're going to do stock B now. So we're still looking at that same question, and they gave us 2 stocks. One was coming down in value. That's the one we just figured out. Now we're figuring out the equation for stock B. Stock B is going up in value. So your B value, it should be a growth. It should be bigger than 1 when you're done. Okay, the initial starting point. Go ahead and figure out how much is that stock worth when you first bought it. That's the y-intercept, 0, 2. So the initial value is $2. So it started at $2 per share. Now we have to figure out what's the growth value. Again, that's going to be just B. Okay, so we need 2 points. So if you look at the graph, it'll give you the 2 points. We have 0, 2, 0, 2, and then we have 1, 3. So in 1 year, that share will be worth $3. So go ahead and use 0, 2 and 1, 3. Remember, it does matter the order. 0, 2 came first before the 1, 3. So this 0, 2, that 2 has to be your y sub 1. Then the next point is going to be your y sub 2. Okay, go ahead and figure out what's the b value. 3. Your y sub 1 is 2. You can leave it like that. 3 over 2, that's already reduced. If you want to make it 1.5, that's fine. Okay, and I'll come up with the equation. It's always going to be y equals, or f of x equals, then a, the initial value, that's your $2, times your b, which is 3 over 2, or 1.5, and then raise it up to your x power or to your t power. So you're just, and if it says to compare them, it's just the stock A, it's a decay. It's coming down. And stock B is a growth. It's going up. Okay, let's try one more like that. Your notes are nice and easy for you to follow. This is the last question we're doing for today, and then we're done. So you're going to have stock A. You're going to need to write the initial value. And then the decay factor. And then write the equation. Then you're going to do stock B. Initial value. This one will be a growth factor. And then you have to come up with the equation. So you're going to have to do this for 2 graphs. Tell me what's the initial value. Figure out what's the decay factor, which is your B. So initial value, this is your A. Decay factor will be your B. Your equation will be y equals A times B to the x. Same thing here. This will be your A, your B, and the equation is y is equal to A times B to the x power. Okay, I'm going to put the graph up here. Okay. So stock A starts up here. And it's coming down. If you can't read this, the points for stock A are 0, 100 and 1, 50. And then stock B, if you can't see these numbers for stock B is starting at 0, 1.5. That point says 0, 1.5, and this says 1, 3. Okay, go ahead and finish this one. Okay, for stock A, the initial value was 100. The equation is 100 times a half to the x power, or 0.5. Stock B, the initial value was 1.5. 3 divided by 1.5 is 2, so your growth factor was 2, and to the x power. Questions on that? Okie dokie. Then today we're done for all of this for the growth and decay. Tomorrow we're going to be doing an activity.